Started. Welcome everyone to another in our series of AI-focused webinars. So we do webinars on crowdsourcing and on AI. Today's webinar is using WhisperAI for audio-visual transcription, and it's presented by Will Hicks at the University of North Texas Library. So Will presented this at the Texas Conference on Digital Libraries in May, and I attended and was blown away. I'm really excited about the work that they are doing at the Portal to Texas History and UNT Libraries, and Will's innovations and explorations are they're just fascinating. So I'm really grateful for Will for being willing to recapitulate that and update it with some of his experiences since then. And I should say, before we turn the floor over to Will, that this is part of a series of webinars that we host. Our next webinar is, and we have got two in October. One is Your First Crowdsourcing Project, which is just about how running, kind of the soft skills of running a crowdsourcing project. Finding volunteers, motivating people, coming up with instructions, selecting material, all the kind of non-technical things.
The second one in October is a recapitulation of a presentation we actually did yesterday for the Institute on Archival Futures at University of Maryland. And if you weren't able to see that or didn't hear about it, we're doing it again, so you can attend that. And then in November, we're going to use a part of ChatGPT called the Code Interpreter, which is really just a way to upload data and do interesting things with it. And we're gonna explore some data sets from the Library of Virginia's Virginia Untold project, which were transcribed on from the page, and then they upload it to the Virginia Data Portal. But I think it's going to be an interesting kind of think about how do you go from a document transcription and then analysis using some of these new tools. So it's kind of our pitch.
Right. So I'm going to stop sharing my screen to turn this over to Will. So Will, you want to take it away?
Yeah, give me a second. Can you still hear me?
Yes.
Okay. I just totally destroyed a USB fob.
No.
Any better? Still working?
Yeah, this works great.
Yes.
Okay. I'm not on my mic anymore, so we'll wing it this way. Okay. So thanks everybody for showing up today. As Ben and Sarah have noted, this is an encore of a previous talk at TCDL, and thus the focus on digital libraries, though folks in other areas will likely get some mileage out of this as well. Since the focus will turn to a couple of software tools, most notably OpenAI's Whisper, I'll note for posterity's sake that I'm using the latest stable March 15, 2023 release on GitHub, since it and its features are likely to change. So caveats and disclaimers. First, some visual and hearing impairment notices. I'll be showing some brief clips, both with and without sound, and in some cases with audio appearing in only one channel. There will be a handful of charts and code samples, and I'll do my best to describe them for anyone needing accommodations. But I originally created this talk with a projected screen in mind, so a few things might be small depending on your monitor. Second, I have slides containing explicit language and possibly other profanities. It's nothing too crazy, but this is your courtesy warning for that. And because this is an AI-themed talk, I've included generative art to fill the white space of my slides. Most of all these you can blame on DALL-E 2, Bing, or Midjourney. And occasionally I will throw a QR code on screen to shortcut you to a resource or two, as well as hopefully Ben and Sarah can toss links into the chat if they find them as well. Okay, so background and credentials. I work for the University of North Texas Libraries and am the front-end developer of the digital repository stack there. And my interest in this area mostly grew out of accessibility compliance work I do for that system. So our systems are the Portal to Texas History, the UNT Digital Library, and the Gateway to Oklahoma History, which currently host about 136,000 videos and sound objects. And these represent about 6% of the total objects on our system, where we're much more heavy in newspapers, photos, and other resource types. Quick plug, Texas-based orgs, we're always looking for new content partners, so tell your friends. For our AV, if you were to exclude a couple of large music collections, it would take you 550 days of continuous playtime to get through it all, and about 800 days with the music. We've had a modest budget line of our own to ship files off to vendors since about 2018. And from 2019 to 21, I was awarded a couple of grants from TSLAC that further covered vendor costs, student employees. And on that dime, we evaluated a range of automatic speech recognition, or ASR, and human transcription options. And that serves as a good baseline for comparison purposes. Finally, starting late last year, we began creating machine transcripts on our own hardware with Whisper, which I'll talk a lot about today. Our collections are fairly diverse in terms of their content and scope, and they include interviews, oral histories, news clips, various types of musical and performance arts. We have sports, amateur films, meetings, promotional media, and demonstrations. Our sound recordings include radio broadcasts, sermons, the list just goes on and on. Date-wise, the coverage is from the 1920s to present, and the individual durations of our AV files range from a few seconds up to multiple hours per file. Paying no attention to the scale of the word cloud on screen, as far as language and speech goes, based on the metadata records we have about them, about 70% of this content is English, with an additional 80 or so sung or spoken languages that make up the rest. It is worth noting that we have a large share of silent and B-roll video with noise and other non-speech sound. And just generally speaking, the range of audio quality across the collections varies tremendously, with some well-mic'd studio sessions, some field recordings, people speaking with impeccable diction, others with heavy accents, crowds, crosstalk. We have some bilingual speech, so just a huge range. All this is to say, our collections are fairly generalizable, and I hope speak to yours somewhat, but there are probably some holes in it. I can imagine, for instance, that we have relatively few recordings with children's voices, and we definitely have plenty of jargon speech in our higher ed scope media, but we don't have a lot of medical topics. So as I proceed, you should consider all these sorts of attributes about your content, as they may have some bearing on the results you can get from Whisper and these tools. So for time's sake, I'm not going to deep dive into AV accessibility or law here. If that interests you, a few of my colleagues and I did a couple of webinars last year, which I've got linked on the screen in QR codes. But I do want to cover a couple of areas here, at least in passing, to answer the question, why would you do this and how close will Whisper or other ASRs get you to that? So generally speaking, users of all sorts benefit from text alternatives to AV content, but probably the two most typical groups or use cases are users who can't perceive, either in part or in whole, audio content and who either benefit from or need accessibility accommodations. And then two, search engine bots, system indexes, and the users who are trying to discover content at a more macro level. For the former, we can be pretty liberal in that interpretation and include folks in the deaf community, non-native speakers, the 70% or so of millennials who enable captions just about all the time, the elderly, and just about anyone who might benefit from a text rendering of the audio. My hearing, for instance, is pretty normative, but I enable captions on streaming services all the time just so that I don't wake my kids up at night. And to the latter point, without a text equivalent, it's typically up to a metadata record of an AV object to do a lot of the heavy lifting in the discovery process. And for us, at least, this can be sometimes a problem at scale. So as an example on top, and with apologies to the folks doing metadata records on this collection, I'm showing you an aggregated listing of the individual object description fields for a video collection that has about 100,000 short video clips in it. As you can see, 40% of those have exact duplicate descriptions. Quote, video footage from the KXAS TV NBC station in Fort Worth, Texas, to accompany a news story. And titles tend to be somewhat non-descriptive as well. To be fair, a lot of these records have decent subject coverage, but those aren't visible in our search results. And with so much repetition, it can be hard to really know what any of this content is about or distinguish between them. So to demonstrate this problem, I've pulled two videos that have nearly identical metadata records. With that in mind, let's watch them without sound. So what are you missing right now? On the left, the reporter is talking about a Soviet boycott at the '84 LA Olympics. And on the right, we miss the news that 4 tickets to see Michael Jackson at Texas Stadium would have set you back a sweet $125 back in the day. And so my contention is In an IR, the text derivatives of the AV content can be really important for accessibility and search. And one would now assume as time goes on and LLMs increasingly become a part of everyday workflows, can also be a good source for extracting metadata as well. And so having a full text rendering of the AV content is the best solution to these two problems. And for that, we're talking text transcripts, subtitles, and captions for the most part. Historically, you would probably vendor this out and pay somewhere on the order of $1.10 to $2.50 per English audio minute, and you'd receive back one of a handful of text-based formats a few days later. Typically an SRT, WebVTT, a plain text file, a Word doc, PDF, or a handful of other file types. In our system, we opt to use VTTs since they are a W3C standard, and create a clickable text transcript for both audio and video files using JavaScript to parse and display them through the UI. Individual phrases are deep linked to their corresponding timestamps on the media player. They're searchable at the local page level and discoverable more widely in our Solr index. And because it gets rendered as HTML, theoretically, the content can be indexed by external search providers as well. And of course, they get rendered as either subtitles or captions when the medium is a video object. The difference in these two types are subtle but important, especially when it comes to dealing with machine outputs and conforming to accessibility laws. So let's watch a video a couple of different times without sound to see the difference. This first one is subtitled, where only the spoken text is being rendered. When we get to the third unlabeled cue, Bush's lips and the text don't align because at that point, a reporter is talking. This can be confusing visually, but also the contextual flow of the text may not make a lot of sense as a written document. And again, we'll watch without sound. So subtitle-like files are the typical outputs you get from many services and are typical for translations that you get from services. They usually don't meet strict legal accessibility requirements, but can be edited to do so. But they do significantly improve resource discovery via search as they provide the full text equivalent of the spoken text. Here, by contrast, is the same clip with captions. Here, both speaker and sound are identified to give the viewer some context when needed. In this case, they distinguish between Bush, the reporter, and the crowd. And this is the style that gets you closer to compliance with WCAG, but it's sometimes tough to do. Some vendors will do it, some won't, and few machine transcripts can do it robustly at all. So how do you create these? If you're lucky, you can acquire them with the original media, especially now in the age of Zoom, or you're more likely going to need to allocate resources to do it yourself or ship the files off to a vendor. So a brief note on vendors before talking about Whisper as part of the story, since you can get both machine and human edits from them. Over the last few years, we've evaluated 6 different vendors, and as far as their various ASR options, accuracy rates seem to depend highly on speaker and recording conditions, and the costs were always very low. Most now appear to operate on a bulk pricing model at pennies or less than pennies per minute. Machines, when compared to people, are always fast, completing work in a fraction of the time of the original recording. And the most common errors we would see were spelling of names, inconsistent formatting of numbers, misinterpretations of homophones, so the 222s of the world, butchering of acronyms, and as is the case with most machines, the outputs tend to just be subtitles. To note speaker IDs or non-speech sounds, you insert them using a vendor's web-based editor, or you download and edit the files on your own. And I will admit that my experience here is now going on 2 years old, so Stone Age stuff, probably. I know that Google and Meta have new ASR models that they're sort of touting as being super accurate. And there's one vendor called DeepGram that just put out some white papers saying that they have lower word error rates than Whisper. They have summarization, speaker diarization, and other features, which just are not built into Whisper at the moment. Incidentally, for those interested, one vendor we work with has started offering AI generative summaries, keywords, and titles as an adjunct to their human or machine transcription service, which I've thrown an example on the screen. As of this date, it's a pretty new add-on, and it's labeled in beta. Again, I assume it's probably just jumping out to the GPT API, but there you go. Compared to machines, human-based services are more accurate in just about every way, except maybe names, but the cost is far higher and the turnaround time is slow. You do, however, theoretically get captions, but in reality, vendors don't always render speaker IDs in a human visible manner. They might put them in voice tags, or they may miss sounds that you might find important in your context as a librarian. Using humans has generally been the course of action you would take, though, if you wanted to ensure you were in compliance with the ADA. And a quick note, too, that as an alternative to vendors, assuming you are in a higher ed like me, you can pay student assistants, particularly federal work studies, to do this work, and the rate probably works out to be about the same. I've had as many as 5 students working on corrections at a time, and the typical personnel things aside, they can be helpful, especially in domain-specific settings, like working with music or other content with specialized vocabularies. But again, the outputs are slow. Last slide before Whisper stuff. For all the Texas-based government-funded orgs on the call, because of TexRamp certification, today you have maybe 2 or 3 vendors available to you in the state of Texas. So talk to your IT compliance folks if you don't know what I mean. Similarly, depending on your content, be aware that shipping it off to a software as a service vendor may raise flags in some office on your campus if the content has some adjacency to FERPA or HIPAA, there's copyright concerns, or if it's IRB content, something like that. And you will still need to allocate funds, execute contracts, do bulk work, and write code against the vendor API. And so what you need to think about really then, the point of this sort of talk is, if you have AV on your servers today and you get a request for captions tomorrow, are you going to be able, or are you going to have a difficult time accommodating that request in a reasonable amount of time? And would you benefit from a faster, localized, open source DIY solution? So then let's talk about Whisper. It was released by OpenAI in the fall of 2022, right before the ChatGPT media blitz, so it sort of disappeared a little bit. Whisper is a pretty easy install on a capable desktop with common developer tools and dependencies like Git, Python, and FFmpeg, but it benefits from beefier hardware specs, as I'll show in a sec. The standard install command is on screen. If a local version isn't your jam, there are a growing number of cloud-based tools and forked projects that let you run it in a variety of other circumstances. We've now processed or reprocessed about 7,800 hours of materials with it. And so I'm going to talk about how it works and show you a bunch of examples of its output when run against things in our collections. A bit about how you use it. So Whisper is a Python-based project and ships, or rather downloads a series of language models, and you interact with them through the command line or by writing your own Python. On screen, I've listed 5 CLI prompts. So in the first example, we see the command Whisper, followed by a file name, a language argument, which is optional as Whisper can guess the language of the files you throw at it, and then another option argument specifying the task, in this case, a transcribe. In the second English example, I specify that I want to run the file quickly, and I use the Tiny model, which is their least accurate but blazingly fast model. And you can watch it process a 2-minute clip in fits and starts on an older 2017 starved Intel iMac using those settings in the 30-second clip on the right as I finish out this slide. In the next, I specify a more accurate but slower English media model, and that I only want it to return a WebVTT file. Other output styles Whisper will produce are SRTs, TXTs, JSON, and TSV. Below that, we see a command for transcribing a Spanish language file. So the file's speech is in Spanish, and I want it to output Spanish text. And finally, there's a command to take a Spanish recording and output an English translation using the largest, slowest, but most accurate model. As you'd probably expect, the larger the model, the more accurate the outputs tend to be, but also the slower they will be to run. And depending on your hardware, you may not get the large model to run at all. As a pre-processing step, Whisper uses FFmpeg to transform files into 30-second mono wave clips and does its predictive speech recognition tasks on each of those successively. It normalizes some of the outputs and then merges the segments back together into your desired output file. In addition to the arguments I've shown on screen, it can accept a number of other arguments, allowing for an initial prompt to try and help steer the output, or to output word level timestamps and a number of other little things. A slide on speed. Here are some of the different hardware configurations we've tried. What this shows is that running on a CPU is always significantly slower than doing so on a GPU. And it should be obvious, the more RAM you throw at it, the better. Note with the arrows, we are comparing the runtime of media models and that the large simply couldn't run in some circumstances on that hardware. That being said, there are a few variant projects on GitHub that are optimized for devices other than your monster gaming machine. I've used Whisper CPP on an older Intel Mac. Works really quite well. I now have a newer M2 MacBook Pro, and the standard Whisper large models run on that. But it's not as fast, obviously, as having one of these killer GPUs. But if you're just doing small one-off jobs, it'll get the job done. If you can't or don't want to do this on your own hardware, OpenAI provides you access to the large model via their API if you are willing to work in Python. Current pricing is something like 36 cents per audio hour, but you are limited to a file upload size of 25 megabytes. So bigger media has to be chunked. And there are other vendors. As with other vendors, you will need to deal with payments, processing, all that kind of stuff that you wouldn't have to do if you were local. Back to the internals of how it works. Whisper was trained on 680,000 hours of time-stamped media with transcripts harvested from the web, and the developers claim to have removed machine-only generated transcripts aiming for precision between sound and text. The source files included a variety of speakers and recording circumstances, so it generalizes different speech rates, accents, and various noise conditions. About 65% of the original sources were English, 17% are in about 100 other languages, and 18% are translations from other languages into English. With regards to accuracy, your mileage is going to vary based on the characteristics of your content, particularly the source language of the file. It tends to be generally quite good if your content is one of the languages at the top of that chart, so the Englishes and Spanishes of the world, and progressively less so the further down the chart a language falls, where many of them are based on less than 1,000 hours of source material. For some English speakers, you're probably looking at a word error rate anywhere from maybe 1 to 10%. And again, it's really going to be very context dependent. If the error rate for some of these other languages is too high for your taste, and especially if you need, if you really need them, there are fine-tuning docs and models over at the huggingface.co website where folks have attempted to improve on these numbers. And I know at least some of these have government funding behind them. The Indian government funded Hindi and a couple of other languages as well. A few other little details for some demos. If it matters to you at all, the normalizers that are built into it favor American English over British spellings. And the outputs, as best as I can tell, there are no normalizers for other languages. For English content, at least, it's reasonable and fairly consistent with numbers and currency format, but sometimes less so when it comes to times of day or other numerical conventions. It also seems to do far better with names and acronyms and homophones than other tools I've used in the past. And although I haven't had a lot of time to evaluate it, African-American vernacular English seems okay with Whisper, it being pretty faithful to many speakers in our collection, but I haven't had a lot of time to really dive into that one. For each of these, you don't really get much, if any, say in the output style without diving into Python code, meaning you get more value doing some post-processing of your outputs. Okay, so I've talked a ton. Let's see some examples. This is a short English clip from 1992 about Texas Governor Ann Richards, generated by the large model. Incidentally, check out the weird foreshadowing in the last couple of seconds of the clip.
The guest list for the governor's party, a virtual who's who in Democratic Party power politics. Cuomo, Foley, Wright, Strauss, Benson, Fazio, Brown, Jackson, and Mondale. They all came to pay homage to the woman who many say they would like to see run for president someday.
So, as you can see, this reporter spoke in a clear and consistent tone, was well mic'd, and Whisper transcribed it almost flawlessly. Here's another one. This one has multiple speakers, is outdoors, and you can see subtle differences in slang, deletions of ums, and the like, but overall the fielding to the original is pretty spot on.
They should have let him in.
Why?
Because I like the guy.
I don't think he should have been even considered for the job in the first place.
Well, I think he got a dirty deal. I think they blackballed the man, something terrible.
John Tower is an egotistical little rascal. He's capable, but he's had too many problems.
We have enough problems without having somebody with problems.
I don't think they should have taken it away from him just saying that he drank. I'm sure most of them up there do the same thing.
It's a shame. He was qualified. Yes, he had some problems, but not no more severe than a lot of other people.
I really don't think he was treated fairly.
All right, so here's one that the source audio has some modest distortion, but note here that there is no separation between the two speakers in the output lines.
Are any new insurance companies going to be under investigation?
We contemplate that some transactions which might involve a couple of small companies will be under investigation at the next hearing of the committee.
Are you satisfied with the present setup of the Texas Insurance Commission?
I think the commission is composed generally of fine people.
So here we can see it's basically a less than ideal subtitle, not a true caption. And at least as far as fixing or editing this, because speakers get merged onto the same timestamp, you'd ideally spend extra time cleaning this up, splitting the timestamps, and you would probably want to fold or split the long lines. Need to add speaker identifiers, and so most likely you would want to do so in a caption editor. And so it's a good time to talk about some of the common problems that you're going to encounter if you adopt this tool. And so here's where it's going to get wheezy. First, it tends to hallucinate and spiral into repeating non-existent text when it encounters long periods of silence or unintelligible crosstalk. The GitHub discussion board is full of questions about this, and there are various proposed solutions people have attempted thus far to cut down on it, with side projects adding voice activity detection or trying to filter content in some way. If you're willing to dive into some of the configuration variables for the script, there are a handful of settings that can be tweaked that potentially reduce this sort of error, but we've mostly just been post-processing the outputs a bit on our side. Mostly this is dumb and annoying, but sometimes the outputs are strange and just sad. Also, sometimes it loses track of sentence casing and punctuation, as shown on the example. Sometimes a whole file will look like this, but often it's just a portion of one. Because the outputs of this thing are just text files, it's fairly simple to do some searches across them. And so you can typically locate these by just doing case-sensitive searches on the word I, or the days of the week, the months, proper nouns, that sort of thing. My latest attempt at post-process script triages this a bit by running the outputs through spacey natural language processing and then capitalizing predicted proper noun entities if they are lowercased. Similarly, there's a handful of libraries floating around on GitHub like rpunct and punctfix, and probably others that are built for casing and punctuation restoration. But in my test on the sort of free-flowing text we sometimes have, it turns out not to work very well. You could also run this through ChatGPT or another of the OpenAI GPT APIs of your choice, or even just Grammarly or the new LLM coolness of the day to clean up the text some as well. And I'll show an example of this at the end, but your mileage is obviously going to vary. All right, more hallucinations, this time with music. When it encounters long stretches of instrumental music, it a little too often thinks it's Edward Elgar's Pomp and Circumstances or the Star-Spangled Banner. Sometimes you do get text renderings that say music or piano or violin, or the Unicode musical eighth note characters. But again, a post-process review is probably in order for content with music anyway. I would assume the reason is that the training data has an abundance of graduation ceremonies and ball games in it, but who knows? As I intimated at the beginning, here's a slide on curse words and profane speech. Again, Whisper makes all its decisions based on the training data, and that data seems to have had some censored text in it, but as you can see, it's not always consistent in the outputs. So I did a regex test for swear and offensive language across all the files we've had it create for us, and I found a little under 1% contained censored text. I then recorded myself reading hundreds of sentences with every imaginable curse word possible, and it never once censored me. So hard to say what's going on here. Similarly, if you have any religious text in your audio too, the note I made a couple of slides back about casing problems is maybe relevant for you as well, since some stakeholders are mighty particular about mistakes in the casing of particular deities. In a library or archive context, I don't think many of you are ever going to want to censor language, but if you do, there are a handful of Python libraries for that sort of thing. But there aren't, as far as I know, going the other direction. So here, I think you're just going to be doing a search for repeated asterisks or the bad word of your choice and doing some manual or programmatic correction. Another super nerdy one, but worth mentioning for this, if you are looking to use this for compliance purposes, we've observed, especially with really long files, that the length of individual caption cues early in a file can sometimes be super long, and that they get shorter and shorter on a curve as the file progresses. I'm sure there's a mathematical reason for this. If you are only interested in the transcript or are working with audio only files, this isn't really a big problem. But as you can see, it gets super weird when you're dealing with video, as you can see on the screen. The fix here, latest build offers word level timestamps and has arguments for futzing with the line links that you can try. Or again, you can do a post-processing step where you split the queue at natural breaks, or just abandon VTTs and SRTs altogether and use the JSON outputs and just sort of do the work yourself. Finally, a bit more before show and tell again. Whisper is capable of doing translations, but they are reliably one way only. So you can go from Spanish to English, but not the other way around, at least consistently. That said, things get weird when you want to transcribe or translate bilingual speech, because Whisper tends to forget what it's doing, and you get unpredictable outputs from it. Finally, and bigly, there is no speaker identification or diarization, so you aren't getting true captions in the case of multi-speaker audio. Having watched the discussion space since its launch, I can say that this is one of the most sought after features, and there are a handful of folks who demo doing so with media that has voices on different audio channels or using silence and voice activity detection prior to the transcription task. On screen, I'm listing a handful of current keywords and projects to investigate if you are interested here. I haven't really deep dived into this part of it myself, but my assumption is if your media is two speakers in back and forth dialogue with ample source separation between the two, then you're likely going to have a much easier time of it than if you have, just bulk data with undefined numbers of speakers, similar voices, and or crosstalk. Those caveats in mind, let's see a few more challenging examples. So apologies in advance on the asynchronous flashing you're going to see on some of these. What I've attempted to do is show you multiple subtitles concurrently in different regions of the video, and aligning timestamps is a complete pain. So this first one is jazz musician Louis Armstrong. It took one of my student assistants days upon days to transcribe this recording, which you will see on the top, and it still has errors in it. The middle is another ASR program for you to compare error rates, and at bottom is Whisper's unedited output via the large model. It's 30 seconds. I'll run it twice so you can read through and compare a couple of the outputs.
Who's that sounding like Louis Armstrong laughing on the background?
I'm enjoying it all, man. Yeah, boys. I just heard sort of feeling in Chicago there. Knocked me out there. The cats whipping them cymbals. One cat run. And run from one cymbal over to the bass drum, and boy, they really had a ball up there. I sang one number with the band. Did you? Yeah. Cats was making them cards, and things behind them. It was pretty. After the blue note.
Right,
Who's that sounding like Louis Armstrong laughing on the background?
I'm enjoying it all, man. Yeah, boys. I just heard sort of feeling in Chicago there. Knocked me out there. The cats whipping them cymbals. One cat run. And run from one cymbal over to the bass drum, and boy, they really had a ball up there. I sang one number with the band. Did you? Yeah. Cats was making them cards, and things behind them. It was pretty. After the blue note.
So the error rate for the human and Whisper pretty close to each other. Whisper, however, finished this file in a couple of minutes. Vocal music is one of those special cases. How does it work out? Not always great, honestly, but you can see that it can lie very convincingly, just like ChatGPT does, with this clip from Gilbert and Sullivan. Again, subtitles at top are truth, the middle is the Whisper large model, and the bottom is Whisper's medium. When I hit play, to the right, I also render a color-coded visualizer that shows some confidence scoring on the text tokens. Red is low confidence, but could still be right. Green is high. And here we go.
I am the very model of a modern major general. I've information vegetable, animal, and mineral. I know the kings of England, and I grew up to fight historical from Marathon to Waterloo and all the categorical. I'm very well acquainted to it, not as mathematical. I understand equations both as simple and quadratical. Without binomial theorem, I'm teeming with a lot of news. With many trivial facts about the square of the hypotenuse. With many trivial facts about the square of the hypotenuse. With many trivial facts about the square of the hypotenuse. With many trivial facts about the square of the hypotenuse.
So obviously, if you're going to go down this path, you'd want to do some edits, but it's a good start for lots of different kinds of content. So I think this is a good example to try and drive home some of the cost-saving values of this tool. Here we see a Spanish language interview that we paid a vendor to transcribe. It is 51 minutes long. It cost $222, and we had the file back in 9 days after its submission. We could not justify the translation cost, which would have run between $500 and $1,200, depending on which accuracy and pricing tier we chose. So let's see how this compares to Whisper.
Ok, para comenzar la entrevista, queremos primero conocer sobre sus orígenes. ¿Nos podría decir dónde nació y cuándo?
Mira, yo nací un 17 de mayo de 1943 y nací en Acuña, Coahuila.
¿Nos puede contar sobre su familia? ¿De dónde es?
Mira, mi familia, mi papá fue revolucionario y mi mamá pues fue una mujer normal, ¿verdad? Hija de familia.
So I can't give you a great evaluation of the translation, but it is at least readable, and it was done the same day. As for the transcript, I ran a diff against the text, and Whisper is something like 90% the same as the human edits, with some of the differences just formatting of numbers, contractions, the lost punctuation during the run, spelling differences in names, those sorts of things. So perfect? No. Better than nothing? That's a judgment call, but it seems worth it to me. Finally, on Whisper, I want to demo one of the most recent variants that's been only out for a couple of months now, but has some interesting potential. This one's called WhisperAT, developed by a research scientist out at MIT. For this one, adjacent to the standard Whisper segment data, there is a secondary data structure that chunks the audio into 10-second intervals and attempts to match the sound against the 527 categories of the audio set dataset, the labels of which are scrolling in the video on the right. As I've played with it off and on over the last few weeks, it does an okay, but definitely not perfect job at identifying non-speech audio events in the media that I throw at it. So this clip is a mashup of 4 short news clips. I'm only rendering the audio tags on the screen, not Whisper's speech. And these are inferred in 10-second intervals, thus the running timer you'll see below them. The last 2 contain some loud sirens and shouting and brief flashing. So the first 2 are 20 seconds each with animals and music. The third is 40 seconds with speech and sirens, but pay attention to the last 10 seconds of that one for what's missing. And the last one, you'll hear a train bell, crowd noise, and a helicopter. And it's about 40 seconds.
Just about everyone has gone through a few anxious days when the family pooch wanders away and you just don't know where your dog is. There's the usual asking neighbors, putting an ad in the paper, and checking the dog pound, all just to get Fido back. Well, now a Tarrant County man is trying to make it just a little easier to recover lost dogs. Don Prager.
For most of us, spotting a ring-billed gull or a brightly colored male mallard is child's play.
Look, he's talking to you.
After that, it may get a bit difficult, so we enlisted the help of expert.
So everybody kind of started freaking out and running around, hooting and hollering, and walked down to your little girl. Yeah, immediately. I mean, as soon as people started yelling, screaming, we picked up and headed downstairs to the library, where glass is everywhere and people are running around. There's some hurt people, kids. Where are the hurt people at? They should be in the library. I think there's some medics down there. Yeah, but there's some. My name's Mark. Nothing. Lawyer. Lawyer? Yeah.
Okay, there was that van that I was telling you a little bit earlier, Mike and Jane. Right now you can hear the emergency sirens as police and fire trucks continue to roll into this downtown Fort Worth area. We're looking...
Okay, so you can see that it's not perfect, but not horrible by any means, given the audio quality in some of these samples. So an interesting project. So how might this be useful? Totally depends on your content. If it's just oral history interviews, probably not at all. But here's a scenario we have. Our music library archives recitals and other performances. These aren't always split into multiple audio or video tracks, and so it can be difficult for the user to locate a performed work buried deep within an hour-long file. And so the user has to seek around a lot. We've historically approached this by creating a chapter VTT file, which gets rendered out just like the captions and subtitles do, as you can see on the left of the screen. But someone has to find the various timestamps and then enter the titles of the work, so it can be time-consuming to do so. One way you might approach speeding this process up is to use FFmpeg or another tool to generate waveforms, like the one above the screenshot, so that you can visually estimate sections within the performance. But WhisperAI could provide a way to shortcut this as well. So at right, you see a snippet of generated output. Here, I fold down any of the several hundred music-related sounds into a simple music playing string, and you can see it alternating with longer moments of silence and applause. So a decent-ish way to sort of identify music. So that's mostly it for Whisper itself, but I'll close out with a few slides on some other interesting things you could do with your transcripts and captions once you have them. One obvious thing is run stats. Over the last couple of weeks, I've updated my post-process script to do some better corrections and logging and reran the whole lot. I said at the top that our Whisper captions amounted to 7,800 hours of material for us. Teased out, that's 8.5 million words of text, with an average of 888 unique words per file and a max of 5,953 unique searchable nuggets of information in the content that I processed. As for reference, by my criteria, about 3% of the cues in a caption file contained identifiable and removable hallucinations. But don't stop there. If you're going to go this far, then you should consider running some natural language processing tools against the text if you can. I'll run out the clock talking a bit about Spacey and OpenAI's GPT tools just for giggles. So I mentioned Spacey earlier as a part of the tool chain I'm using to test for capitalization errors for Whisper. Spacey is a freely available natural language processing library for Python. It's pretty easy to work with and has lots of applications in the digital humanities space. On screen, I'm demoing one of the annotation rendering tools that it ships with, which highlights named entities in a given text. So imagine you transcribed a city council meeting and you want all the names of parks or legal documents mentioned. This can help with that sort of thing. Spacey ships with the ability to recognize about a dozen different entity types, and you can teach it custom ones or let it find patterns and do fuzzy search if you have semi-specific but squishy needs. And while you can do pretty visualizations, why not get specific with named entities and transform them a bit? So here's some code that I just threw together that would grab only the people types, invert them into a last comma first format, and then dump them to a list with their occurrence counts. And so thus you have a way to identify potential spelling errors for correction purposes, or possibly for generating subjects, creators, contributors for your metadata records. It also has a tool called TextRank that can extract keywords and phrases from a document. Here I've run a quick script against a news clip in our collection and have gotten back a TSV-like listing, which might nudge me to add some subjects about the Dallas Cowboys for this piece of content. Again, you could do this on various other entities as well in your media. If your media is short enough, you could create extractive summaries as well of the spoken text. But the longer your text, the more that gets a little dicey. Finally, I want to conclude with a super high level look at the GPT in this space. Because of time and text rent pay-for prohibitions, I haven't done API work here, but I think you probably get more or less the same mileage out of the web interface and should give some of these concepts a whirl yourself. Also, apologies to future viewers and future me if this is being posted online somewhere. This is super on-the-fly prompt engineering from early days, so don't judge me. Anywho, first, enter a prompt and tell it how to act. So here I say, act like a librarian who knows a little bit about search engine optimization. 2, enter your data in whatever format you have. I think YAML is a compact structure format, so let's do that. To the right is a record exported from the portal, and I've added a generated Whisper transcript to that data structure. And then give it instructions and be ready to iterate over them. Here I ask for a summarization of all the available data, including the transcript, to give me a list of names formatted as last comma first, to generate keywords, LCSH terms based on the summary, and to invent a better title, because remember, my metadata wasn't so great. Here's an iteration of the description that it came up with. For time's sake, we'll sort of blow past it real quickly. It's far more readable than the extractive one that TextRank would do, but asking it to be an SOE expert makes it like super cringy. And so iterating more is probably obviously a good idea. Here's a list of keywords, kinda, sorta, subject headings, names, and titles. Most appear at least somewhat reasonable, but only 2 of the 5 LC terms appear to me to be valid and appear in id.loc.gov. 2 more are pretty close. So clearly not perfect, but I imagine you can see there's a lot of potential here for building metadata from Whisper outputs. And I'll conclude with one look back at our Gilbert and Sullivan example from earlier and make a final practical note that if there is a ground truth text, like saying a known libretto or of this famous comic opera, that you can pretty easily paste in a Whisper output and ask it to correct the text while maintaining the timestamps, and it will happily do so. It might still lie, but you've got a better chance of some corrections. That's pretty much it. So I'll stop reading from the cue cards and answer questions if there's time, and there's some robots to look at.
Wow, thank you so much, Will. This is absolutely fascinating. So let's open the floor for questions. First, we've got a couple of comments and a comment and a request from Kalila. They say that they translate and could say the translation was pretty good. So your Spanish to English example was pretty impressive. They also were curious about seeing some of the code. So do you have a GitHub page where we could see some of your scripts?
At the moment, it's not on a public GitHub. It's on a localized GitLab. Maybe we do sort of tend to like rely on just like local data structures and all that. I just sort of assume with where I store things and all. So maybe I'll get it out there at some point, but it'll be findable.
Okay. So does anybody else have questions? You could raise a hand or type something in the chat. We've got about 10 minutes left. Okay, we've got a question from Devon Murphy, who wants to ask a question that they didn't get to ask at TCDL. Is there more info about what content was used to create the Whisper training set? So greater detail.
You can read the paper, and it talks a little bit about it. I think they're obviously, they're not gonna be able to tell you everything. If you look at the hallucinations that come out of it after a large amount, you can see that there are transcriptions from amara.org, which is an open source sort of like sharing site. There's some that are from otter.ai. This is just like hallucination outputs that you see at the end of the thing, like, and I'm pretty sure there's Rev stuff in there too, but it's harvested from the web, YouTube, just sort of anything randomly that they can find and then tweak.
Our next question is, how do you edit the captions that need extra work? Or I guess your students edit, depending. So do you go directly to the VTT file or use an editor like Cadet? Like what's the correction workflow there?
So honestly, like we've sort of triage a lot of this and just throw it up. I do have a student who does edit it through GitLab, just the text file of a web VTT. We've experimented in the past using VTT editors. There's a really nice one out of a guy in Canada that I like a lot, has a lot of features. I can't remember the name. I just like closed caption create or something like that. But for like, we have a lot of really short, like 1-minute clips. And so using a full-fledged caption editor starts to be a little time consuming. Just that's our experience so far.
So we've got a question from Victoria. Do you have existing metadata fields to put this data in your content management system, or are you packaging it up and putting it elsewhere?
So yeah, our system is sort of a hodgepodge. It's not a content DM or anything that most people have access to. The way we handle this is it's sort of a bolted on system where all of the caption files get named in a similar naming convention as the IDs in the system, the ARC identifiers, and then they get stored in pair trees in a Git repository. And so there's a small bit of metadata in a note field at the top of each VTT file. And then as we edit them, they live on the file system, I commit them, and then a batch script every 30-minute runs and updates them on the site and in the Solar Index. That's not my normal like I don't do any of that part of the system, but that's the major way it works. And that's also a really good way of like dealing with like bulk versions of these text files too, because I use the Sublime editor. And so you can do like regex searches across, thousands of files at a time and edit lots of stuff all at once. It makes it really easily if you're not going to do true programmatic work against them.
When you look at one of these video files on the portal to Texas history, do you see the VTT?
You see a rendering of it that we attempt to do, like that transcript is a parsed version of it using old school Ajax, whatever you call it nowadays. On any video or audio object that's like its about page, if you scroll all the way down, we have a like links for robots section, and we include the VTT in there. I totally imagine that like at some point we make like data, like a data structure out of these things or something, like a shareable data set, because it just is interesting stuff.
I would say the portal does a better job of figuring out how to display all these derivatives than almost any system that I've seen. I know Victoria was asking, and I know she's curious about that. So
yeah, and it sometimes comes up. We do support IIIF, but not the most recent version of it. So we don't have the video audio capability of IIIF renderings on our site, and so we're not doing that as annotations on there at the moment, at least.
So Daniel asks if you could speak to scripting this work across large numbers of files, which reminds me that I'm not sure that I caught the section here that I remember from your TCDL presentation about the provenance of these GPU computers that you were using for a lot of this work.
I guess that's kind of two different questions in a way. So the GPUs, we started out like we were at first just running this on a box that we had that did not have multi GPU cores, and I am not a hardware guy, so apologies. But it was doing okay, and so we wanted to test it out on a gaming box which had multi-core GPUs. So we, during the winter break one year, commandeered one of like the gaming machines in our gaming library, where they do all the games of the day. I forget what they're called. And it was just blazingly fast. So then we bought a multi-core machine to run in our stack. And again, that's not my area of expertise. And so the way we script this so far, generally speaking, is that all the objects already exist in our system. We've already uploaded them through like existing workflows, and then we run batch processes of bash scripts against them. So we're basically just running the command line Whisper against them as like, big lists. And then it's spitting out, the WebVTT files. They go on the file system, move them around with file utilities. That's basically how it works.
Okay. Other questions? Drop them in the chat, or if anyone would like to unmute themselves or raise a hand. Another couple of minutes.
Drop the link to our next webinars in there.
Yeah, let's okay. I'm gonna drop a link to those other webinars we have coming up in the chat.
We'd love to see you at one of those as well.
Yeah.
And thank you for coming.
Yeah, thank you all for attending. We really appreciate it. And big thanks to Will for presenting this. This is fantastic work.
Yeah, thank you guys.
Okay, we'll wrap it up. So thanks again, Will. We really appreciate it.
Yeah, sure. It was fun.
Yeah.
And I'll email you, and we'll set another meeting in another week or two to have a further discussion.
And we will send something to you. We just saw something really interesting on better techniques for creating summaries that are more info dense than the ones you typically get out of GPT that seem very relevant to your last couple of points. So
yeah, that's cool.
We're looking at. So, all right, cool. Well, we'll be in touch.
Okay, bye guys.